Are you?
Yeah.
Good. I thought, it looked like they were like setting up like a music thing, and so I was thinking maybe I would go grab my husband and kid and go hang, but, okay. Let's see here. Have you reviewed radicals yet with Mrs. Zigai, or no? Or the fake Mrs. Zigai? So on this first example here, I wish I brought my other one, just breaking down cubed roots instead of square roots. We're looking for perfect cubes, so you know your perfect cubes are 8, that's 2 cubed, 27, 3 cubed, 4 cubed is 64, so we're looking for something that goes into 135. Do any of those? 27 maybe? I'm hoping. 5 times. Okay, so we would break down, I mean, depends on how she structures it, but I typically would take the 135 and do the cubed root of 27 times the cubed root of 5. And then you're looking for, like variable-wise, you're looking for anything x to the 3rd, x to the 6th, x to the 9th. Those are the types of perfect cubes for variables. So an x to the 4th, I would break down into the cubed root of x to the 3rd times the cubed root of x. So just breaking down that to x cubed times x. And then the y to the 8th, I would break down into the cubed root of y to the 6th times the cubed root of y squared. And then a certain number of these I know the value of. This one, and this one. So the cubed root of 27 is just 3. The cubed root of x cubed is just x. And the cubed root of y to the 6th is y squared. And then the 3 kind of lone soldiers that I don't know the cubed root of just stay underneath the radical. So 5x y squared. I would actually be kind of surprised if something like that was on your Regents that straightforward. The ones that you guys will typically get, and I can grab one here quickly and show you, and I'm sure you've seen them before, with radicals. Hold on, it's in one of these. And if it's not, I'm going to make it up. Like something like this. Have you seen stuff like this? It's kind of a mixture of cubed root stuff and exponential stuff. The bigger key point I have found in Algebra 2 is understanding how a cubed root turns into a rational or a fractional exponent, right? So I always tell my kids, change everything into exponents first. Simplify it based on exponent rules, because that's what you're more familiar with. And exponent rules are a little bit more clean-cut than the radical rules. So I would take this and I would make it x to the 8/3 on the numerator. On the denominator, a power to a power gets multiplied, so x to the 4/3. And then when everything's all exponents, you're just following your exponent rules. So dividing by common bases, we subtract. So the 8/3 minus 4/3 would leave you with x to the 4/3. So that all simplifies to x to the 4/3, and so they're asking you, what does y equal? X to the y power, x to the 4/3, so y equals 4/3. Does that make sense? Okay. This little stipulation here where x has to be greater than 1, don't let that confuse you, okay? Sometimes they have to throw little things in like that because this wouldn't work if x was 0, right? It would be true for a lot more values of y other than 4/3 if x was 0. And same for negative numbers. So they just make it greater than 1, so it's for all, positive numbers greater than 1. And there's reasons why it doesn't work for things less than 1. So they just put that there, but don't let that throw people off. Okay? Sometimes they'll do that, and I know kids get thrown off by that. So that's really more of what I expect for cubed root stuff, but that's not to say they might, they couldn't have something this straightforward. But I really do expect like fractional exponent stuff. The second one, the I values, I have Morgan, did you have a chance to look at the new flashcards that I put up? We have a list of a whole bunch of flashcards of things that you should just know, like little tidbits of information. And one of them, I keep adding to it. We're up to like 50 now. But there's a lot of formulas you guys have to know. But I is just I. I squared you should know is -1. I cubed is -I. And I to the 4th is 1. So that whole cycle is important for simplifying things. And from what I've seen, mostly I've only seen like I cubes show up. Definitely I squared is going to come up, and knowing that that's -1. But in the event that, you know, something to a higher degree comes up, we should know that this is a continuous cycle. So this is I to the 4th, this would be I to the 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, and so on. So this one is always a multiple of 4. So if I have like I to the 21st, I'm going to know that this is I to the 20th, because 20 is a multiple of 4. It'd be 4, 8, 12, 16. And then I to the 20th, which means I to the 21st would just be the same thing as I. So for I to the 7th, this is 4, 5, 6, 7. I to the 7th is going to be the same as I to the 3rd, so that'll be a -I. So A times -I plus B times I to the 16. Now 16 is a perfect multiple of 4. So that one's just 1. Right? So B times 1 minus C times, and then the 21st again, if that's the 20th, then the 21st is just going to be I. So minus C times I. And then simplifying that. So -AI, and I'm going to put the minus CI there as well, plus just a B. And if you look at your answers on this one, nothing really matches that exactly, but that's because, what have they done? In these 3 cases anyway. Right, they factored out the I. So if I take the I out of this, and they probably would take out a -I since it's leading with a negative term. So -I, and that'll make it A plus C, and then plus the B at the end. So it's not exactly the way they have it written, but which one is it? 2. Yep. We've got the positive B, which really eliminates all the others, to be honest, because all the other ones don't have the positive B alone outside. But then the -I, there's your -I, and then A plus C. So with imaginary numbers, especially if it's an open response, you can never have an exponent on an imaginary number to end a problem. So some of the ones have been simplifying, and if you simplify something to 5I cubed minus 7, that won't be correct, because that's not simplified. You can never have an exponent on an I to end a problem. So whatever the exponent is, you've either got to change it if it's I squared to -1, I cubed to -I, and so on. So 5I cubed would be 5 times -I minus 7, which would just be -5I minus 7, and then we don't have the exponent on the I anymore. Does that make sense? Okay. A little more on imaginary numbers, just in the context of solving a quadratic. If the solutions are imaginary, you should know that the quadratic never does what? Right. So pretty straightforward. If you have an imaginary solutions, your quadratic should never cross the x-axis. And actually, that brings me into like types of solutions for quadratics. Okay, when you solve a quadratic, there's really 3 different scenarios. You could have 2 real solutions. You could have 2 imaginary solutions. Or you can have 1 real solution. And this is all dependent upon what happens underneath your radical in the quadratic formula. So underneath your radical, what you're taking the square root of is b squared minus 4ac. And if b squared minus 4ac is a negative number, then you're going to be taking the square root of a negative number, yes? And you'll get your two imaginary solutions. So the two imaginary solutions come from when b squared minus 4ac is less than 0, aka negative. If it's two real solutions, well, then you're taking the square root of a positive number. And so that's going to come from when b squared minus 4ac is greater than 0. And with one solution, that really it's tied in with two things. Number one, what happens with the radical, but the fact that there's a plus or minus prior to it. So normally if it's a square root of a positive number, if you add the positive number versus subtract the positive number, you're going to get two different answers, hence the reason why both of these provided two answers. When it's just, if this ever was 0, the square root of 0 is just 0, so when you add 0 versus when you subtract 0, you get the same answer twice, aka you get only one answer. Does that make sense? So this is going to be when b squared minus 4ac equals 0. So the way this question is worded, 4x squared plus bx plus 7, which of the following values of b will make the equation have real solutions? I would actually guess that this would be more of an open response. This is what I've seen come up as an open response. So without guessing and checking, if we want this to have real solutions, then we want the discriminant, which is this b squared minus 4ac thing. So that would be b squared minus 4 times my a value of 4 and my c value of 7. If we want real solutions, we want this to be greater than or equal to 0. I put greater than or equal to kind of cover both of these cases because they're both real. So I put the greater than or equal to. And so if we just solve this to make sure our b squared minus 4ac stays at or above 0, oh boy, 16, I'm going to add this over. 4 times 4 times 7, 112. So if I add the 112 over, I get b squared is greater than or equal to 112, square root of both sides. So you want b, the square root of 112, 10.6. Now this is a little bit tricky because when you take the square root of both sides, what do you need to remember? Plus or minus. And with an inequality, that's a little bit tricky. What I technically wrote there is not wrong. Let's pretend we're forgetting about the negative for a minute. If it just had to be greater than 10.6, greater than or equal to, we don't have anything on there. We don't have an option that's greater than 10.6, right? But with the inequality, that also means it could be less than negative 10.6, going that way. Because think about it, something like negative 11, when you square it, will be 121. So that would satisfy it. So you could, it's either going to be between the two numbers or outside the two numbers. But finding something that is more extreme, I'll just put it that way, more extreme than 10.6, so that when you square it, it's greater than 112. And more extreme than 10.6 on the positive side would be that way. More extreme than negative 10.6 on the negative side would be numbers further from 0. Any questions on that? There is a good sample problem on, I thought maybe, on that discriminant stuff. Maybe not. The sample I'm looking at sample problems that never showed up on an exam, but last year, because there were no exam practices to work from, that's what they gave us to use as practice problems. There's not a ton of them, but Like I said, I'll show you those at the end with our extra time, because I'm sure we'll have some. Okay, solving a system algebraically. So I always tell my kids, there's a couple types of systems that you might have to solve. Systems in 3 variables, which is kind of its totally own category. And I think probably, like with X, Y's, and Z's, I think we're probably okay with that. But then systems algebraically, and any time, at least in Algebra 2, if it's going to be a system algebraically, it's going to be a linear, which this one's a linear equation, with something else. That something else might be a rational, like a fractional type equation. It might be a quadratic. It might be a circle. It might be, in this case, a radical, but it's going to be a linear and something else. So the only real method you have to use is substitution. Okay? And I would even say that this one's probably written a little bit easy because they already have y all by itself. But you would go to the linear, whatever the linear of the 2 equations is, the mx plus b one, and solve for a variable. This is already done. And then you just essentially take it and plug that in to the other equation for the variable. So 2x minus 9 would equal the square root of x plus 10 minus 1. And then you're just solving the radical. So with radicals, get the radical all by itself. So if I add 1 to both sides, my radical's all by itself. I get my radical all by itself so that I can square both sides, which will be a nice clean elimination of the radical over the x plus 10. On the other side, I have to square that out, like 2x minus 8 times 2x minus 8, which hopefully we can do in our head by now. If not, take the time to write out 2x minus 8 times 2x minus 8. But you should be able to square something like that in your head. You're going to get minus 16x twice, which becomes minus 32x. And then negative 8 times negative 8 is plus 64. But again, if you can't do that in the shortcut way, then take your time and go through the foiling. But that's what you would get there. And then anytime you're solving a weirder function, and by weirder I mean a radical or a rational with fractions, everything always ends up turning into a quadratic or a linear. And this obviously has just turned into a quadratic type of equation with 4x squared. So from here we'll just get it equal to 0. And then solve, and this is not the nicest thing in the world, is it? How would you guys solve that? You would use the formula, which is going to be big numbers. And we may have to, but can I cheat for a minute? I know it says algebraically. I've done a lot algebraically, and you can kind of fudge what you do algebraically if it's possible. Watch, you tell me how I'm going to use my calculator to cheat. I'm going to type it in. I see that. How is that going to help me cheat? Right, with the factors. If I can look and see 1, 2, 3, 4, 5, that looks like a factor of 6, I think. I'll just check, just to be sure. Check my zeros. Pretty sure it's 6. Oops. Yeah. So if I know 6 is a root, I can pretend like I've guessed and checked factoring, and x minus 6 is going to be one of the factors. And then what does the first term then have to be of the other one? X times what gives you 4x squared? 4x. And negative 6 times what gives you 54? Yep. And so anyone reading my test doesn't know that I cheated, right? But I feel like I saved the quadratic formula, right? So they think I guessed and checked factoring, whatever. So my answers are x equals 6 or x equals 9/4. Why am I not done? Not even there yet. Right, when you're sometimes when you're solving a system, they will say, what are the x values, and then you would be done. But there's clearly 2 points where this graph of this rational is crossing this line. So we need to find the actual y coordinates. So far I have 6 comma something, and I have 9/4 comma something. But I have to find my y coordinate. This step is fairly straightforward. I'm not sure you even need to show any work for this. If x is 6, you'll just go back up to where you had y equals. And if x is 6, then 2 times 6 is 12. 12 minus 9 is 3. So there's 1 point. And then if I plug in 9/4, well, there I might need to use my calculator a little bit more. 2 times 9/4 minus 9 gives me negative 4.5. And again, it says to solve the system algebraically, but you should always use your calculator to check. I would do that. I don't know your first name. Luke. I would check via the calculator versus checking by hand, just because we can just type in both functions, x plus 10 minus 1 and 2x minus 9. So there's our radical graph, and here's our, now that's funny. Why did we only get 1 solution, but we got 2? What did we do wrong, kids? 6-3. Why did we not? Oh, I think I know. You could. 2x and 2x would be an option, but we definitely, did we not factor? No, this is factored, right? X times 4x is 4x squared. We got negative 9x, negative 24x, which combines to be negative 33x, and negative 6 times negative 9 is 54. This is tricky. I now know what happened, but it's not that we didn't factor right. I've never seen one come up like this. This is extremely tricky, but note to self, that's why we check on our calculator. So we know something's not right. We got a solution of 6-3 on our calculator, but we had this other one that did not work. And so, I guess worst case scenario, you know that the only answer is 6-3. Your calculator's not lying to you. Just write reject there. You'd get full credit whether you knew why or not. But I'm going to explain to you why, which hopefully will make sense. You know how I just said something about all the weird type of equations? Like anytime you're solving like a weird type of equation, in other words, not a linear, not a quadratic. Linear and quadratic solving is technically Algebra 1 stuff. We do it all the time in Algebra 2 because we're doing higher level stuff, so we have to use that. But linears and quadratics are Algebra 1. All the Algebra 2 solving, rationals, radicals, polynomial graphing things, you can get extraneous solutions, right? Mrs. Big Eyes kids, have you heard that term? Okay, so when we were solving this radical and we got our 2 solutions, one of those solutions didn't truly work for the radical. So when you're solving radicals, you get solutions. You should check those. So going back to Luke was right after all. Maybe we should have checked those answers. Not so much check them in the system, because we weren't done solving the system yet, but just making sure they're both solutions for the radical portion. So if I had plugged in 9/4 way back here, 2 times 9/4 minus 9 on the left gives me negative 4.5 on the left. And then if I plug in on the right, the square root of 9/4 plus 10 minus 1, I don't get the same thing. Do we follow? So plugging on the left, I got negative 4.5. Plugging on the right, I got 2.5. So truthfully, we should have rejected that way down here. I've never seen that in any of these Algebra 2 questions so far. I've never seen you have to reject something due to the extraneous and then only have one answer for your system. But I'm glad we did, because that would not surprise me if something like that came up on the Regents, because all of your teachers would be like, what? How dare they? Why would they do something so nasty? But at the end of the day, we're using our calculator to check that our algebraic work is okay, and that's going to help us figure out something like that. But if you rejected it here at the end and you didn't really technically know why, you'd get full credit. Your algebraic work is there, is your good. Okay, does that make sense? All right. What is this? Getting a little into trig. Just knowing the term coterminal. So we're totally switching gears here. Coterminal with an angle of 130. So 130 is in the second quadrant. And so we're looking for something here that's also in the second quadrant. Essentially with coterminal, you just keep adding on full circles, right? So you can either add 360 to that or subtract 360 from that. So I'll just subtract 360, I get negative 230, and that's the one. Had I added 360, I would have gotten 490, which is not an option. I could add 360 over and over again, we get a coterminal. That's straightforward. Okay, the minute hand of a clock is 3.5 inches long, so you've got a clock. I'm a big fan of pictures, not an artist, but big fan of pictures. You've got a minute hand that's 3.5 inches long, and its tip is rotating through a distance of 8 inches. So let's say its tip starts here and ends here, and that's a distance of 8. Which of the following is closest to the angle that it rotates? What formula is this? Morgan? No. Pythagorean theorems with right triangles. The SOAR formula. Anytime you are looking at like an arc, like a circle and an arc length, this is your SOAR formula. So your arc length is 8, your radius is 3.5, and we're solving for theta. Okay, so just 8 divided by 3.5 is going to give us a theta equal to 2.286. Theta in this formula is always in radians. Are we okay with that? Okay, even if they gave you degrees, you cannot plug degrees into this formula. You'll get the wrong answer. If they gave you the degree angle, you'd have to convert it to radians before using it in this formula. So that's a key piece here. But to turn radians into degrees, what do you multiply by? Right, so that many radians times 180 degrees over pi radians. I like to show the units because if you want the radians to cancel, you want the radians in the denominator. So the radians cancel, and then we'll just take that number, multiply it by 180, divide it by pi, and we get 130.96. So that's your degree angle, and we're there. Okay? Any questions on that? I just went over this yesterday with my kids, but we don't talk about radians much in the sense of like, what's 2 radians, where's 3 radians, where's 4 radians. Everything radians we run into is usually like pi over 6 radians or, right, 3 pi over 4 radians. So when someone says to us like 2.2 radians, we don't usually have a good context as to where that is. But I reminded my kids yesterday that in the unit circle, if that's 0 radians, and this is obviously pi is 3.14, right? So this is 1.57, and then this is 1.57 after 3.14, which is 4.71, before we get around a full circle to 6.28. So if you wanted to place, where is 2.3 approximately, it's got to be something in the second quadrant. Do we all see that? And if you look at your angles, the only 2 that are even in the second quadrant are 1 and 2. So in the event that you might forget how to convert, you can still kind of place where approximately that many radians is, if you know obviously 0 and 3.14, and then 1.57 is halfway there, and then halfway back to 6.28. That helps you place your radians. So if I said 5 radians, you would know that's a fourth quadrant angle, somewhat closer to the 270 degrees, right? 5 is closer to 4.71 than it is to 6.28. And I think that's how you could differentiate here, because 2.286, 2.3, let's say, is almost halfway between these two, right? Maybe a little, it's almost halfway. 174 is not even close to halfway. 174 is clearly much closer to the 180. Okay? Point lies on a unit circle whose x-coordinate is 1/4. I'm, again, a big fan of draw the picture. You've got a unit circle. A point is lying on the unit circle with an x-coordinate of 1/4. If you have an x-coordinate of 1/4, you could be in the first quadrant, or you could be in the fourth quadrant, right? They're telling you it's the fourth quadrant one, so we've got a point on our unit circle down there. I always tell my kids, now draw the terminal ray to that point and complete your triangle. So we draw the terminal ray, and we always drop an altitude to the x-axis so we have a right triangle. Yes? And if the x-coordinate of that point was 1/4, then that's the length to get out there, so 1/4. And they're looking for the y-coordinate that you would need to drop down. But you know the hypotenuse because it's in the unit circle, right? So if it's in the unit circle, that's 1. This is a Pythagorean theorem question because we have a right triangle and we know 2 legs. So 1/4 squared plus your y-coordinate squared is going to equal 1 squared. 1/4 squared is 1/16, so I would subtract 1/16 from both sides. That's going to give me y squared equals 16/16 minus 1/16 is going to be 15/16. And then when you square root both sides, again here, you're square rooting both sides. So your actual equation would have plus or minus. Then we have to think in the context of the problem. Is your y-coordinate here going to be plus or minus? Negative. So we're going to take the negative square root of 15 over the square root of 16, which is 4. Okay? And it wouldn't surprise me if they had negative root 15 over 4 and positive root 15 over 4 on the Regents, because they want to make sure you can differentiate between those two. But big fan of unit circles and drawing your point and completing your triangle, because it makes a whole bunch come to light. Okay? This first one is sort of a cupcake, I would say. We might do something more with this in a minute, but 10 sine of 2x plus 8, and they just want you to evaluate f of pi over 4. So I'm just plugging in pi over 4. And if I were to do this on my calculator, what mode would I need to be in? Radians or degrees? Radians, because I'm taking the sine of an angle. Pi over 4 is in radians. So that would be 10 times the sine of pi over 2. 2 pi over 4 is going to become pi over 2. You should know the sine of pi over 2 is what? Did Mrs. Big Eye make you memorize your table? The sine of pi over 2 is not 90. Pi over 2 is the radian version of 90 degrees. But what is the sine of 90 degrees, or the sine of pi over 2 radians? Did she have you do this? Hold on. Nothing. I mean, you have your calculator, so you really don't need it that much. But if you probably memorized the 0, 30, 45, 60, and 90, right? And you did it for sine, cosine, and tangent. That sounds familiar? The sine column goes from 0 to root 1 over 2 to root 2 over 2 to root 3 over 2 to root 4 over 2, which is just 1. Right? Did she ever show you that pattern? Root 0 over 2 simplifies to 0. Root 1 over 2 simplifies to 1/2. Root 2 over 2, root 3 over 2, and root 4 over 2 simplifies to 1. And then the cosine column is just completely backwards. So root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, and root 4 over 2. Do we all see why root 4 over 2 becomes 1? Right? And then tangent, kind of its own thing. Tangent, you really can just take sine and divide it by cosine. And so you'd have to do a little work on some of these, but it's just 0, root 3 over 3, 1, root 3, and then the sine. Do you remember that? Okay. So 0, 30, 45, 60, and 90, obviously in degrees, converts to the radian measures of 0, pi over 6, pi over 4, pi over 3, and pi over 2. Yep. Nope, it's just going to be trig stuff. So you have to know anytime you're graphing a trig function, make sure it's in radians. I would say 90% of the time on the Algebra 2, it should be in radians. But if you ever have something like, what's the sine of 63 degrees, and there's a degree symbol there, you got to make sure you change it. Then I would change it right back, because you're probably going to just come across, most things are naturally going to be in radians, and I wouldn't want you to forget. And you'll also have your calculator reset before you take the exam, but radians is the default, so it should be in radians. Once the teachers come around and clear all its memory, it will, by default, set it back into radians, which is a good thing for you guys. For geometry kids, they usually have to go and put it back into degrees, otherwise their whole test will be off. But for you guys, you would just leave it in radians. Okay? So the sine of pi over 2, we now know is 1. So 10 times 1 is 10, plus 8 is 18. Okay? You're going to have trig graphs on there, whether you're going to have to sketch your own based on a word problem and write your own equation, or, answer some multiple choice question. You're definitely going to have, it probably will come up 2 or 3 times. Here they are giving us a graph. Let's just review quickly that A is your amplitude, right? We know that. What does Mrs. Zig tell you about B? She says frequency, okay. But my feeling, it is the frequency, but frequency isn't a concept that really has come up often. So what do we say, Morgan? Right, well, it's not, we don't say that it is the period. We say that it helps you calculate the period. Really, the whole purpose of B is to help you calculate the period. So we can say frequency, but also it's used to calculate the period because period equals 2 pi over B. I'm sure you guys do that formula, right? And then K is your midline. Is that what you guys call it? Okay. So in this case, just given the points that we have, what do we know? Let's start with the amplitude. What's the amplitude here? Luke, did you get the amplitude? Would you say 4? Yeah, because your midline has to go down the middle. Makes sense. And so if we're at 3 on the minimum and 11 on the maximum, halfway in between there is going to be 4 units above and 4 units below. So it'll be at 7. So this is 4 units above 7, and this is 4 units below 7. So your amplitude is 4. Your amplitude is 4, so I should say the absolute value of A is 4. But is A itself actually positive 4 or negative 4 here? positive because it's starting at a maximum. So this is a cosine curve. It's starting at a maximum, and so your first cycle is ending at a maximum. So I give my kids these 4 charts. So I kind of do a little space right here. This is a positive sign versus a negative sign. Okay, and we know sine curves because they start and end on the midline, right? The positive ones go up first before they decrease, and the negative ones go down first. And then a positive cosine starts at a maximum, ends at a maximum, and a negative cosine starts at the minimum, ends at the minimum. So because this one is starting at a maximum, it's a positive cosine. So A itself is actually 4. But it's something you should process because the amplitude is always positive. But the value for A can sometimes be positive or negative. What is so like, this is why I don't really talk about frequency much. If I just said to you guys, like, look at this, what's your frequency? How would you do that? Yeah. Right, so you're still taking the period, though. So you're still doing it, like, kind of my way. I don't really think we look at much and say, oh, the frequency is this. It's very rare that we get the right picture that shows us from 0 to 2 pi where we can say, oh, there's 5 cycles in there, the frequency is 5. It just doesn't come up much, so we don't talk about frequency really at all. But we would take to find B, we would take the period, like you just said, and the period is pi over 3. That's the length it takes to complete one cycle, and we would plug it in for the period and solve for B. So we would do pi over 3 equals 2 pi over B. We would cross multiply and get B times pi equals 6 pi, and then divide both sides by pi, and B equals 6. So we've got an A of 4, a B of 6, and our midline we kind of already processed because we were looking at amplitude. The midline was at 7. So K is 7. Which of the following is the value of B plus K? 13. Okay? Okay, this is the kind of like word problem that I'm talking about where they might give you a scenario and ask you to write your own equation, but I would almost expect it to not be a multiple choice. I was really confident last year that one of the open responses would be giving you some information, allowing you to plot your own graph, and then writing the equation accordingly. So rather than giving you the picture, kind of giving you enough information to draw your own picture, like a real application of where trig is found in the real world. So for this particular one, I'm going to just ignore these for now, even though there might be an easier process of elimination way of doing it. I'm just going to do this from scratch. The volume of a water tank varies periodically. You see periodically, you should immediately know, okay, this is a trig question. At t equals 0, I'm going to sketch this, and t is time. We're at a maximum of 650. So that's the point 0, 650. Right away, I'm starting at a maximum. So what kind of curve is this? And more specifically, is it a positive cosine or a negative cosine? Positive. So as far as multiple choice, I'd be done. Right? I'm pretty much done. Because if I've already narrowed down that it's a positive cosine, I'm pretty much done. Not that we shouldn't complete it, because I'd be more confident that this would be an open response. And at t equals 5, it's at a minimum. So 1, 2, 3, 4, 5-ish. We're at a minimum of 120. So 5, 120. Okay? So what would you do first here? That's all and then they just say, let's just say it's an open response, and they say, write a function. What would you do first? Okay. There was no right or wrong answer. You could find the midline, so that's going to be halfway between 650. You know what? And this is one of the things that's on on my kids' flashcards. Technically, we do this, but we'll talk about that C value. They have to know the format of how to write a trig function because you're going to have to at some point. So if we find the midline, we're technically finding D. It's got to be halfway between 650 and 120, so I'm just going to average those together. 650 plus 120 divided by 2 gives me 385. So I'll just put that in there, 385. So D equals that. Okay, what else? So we got D. Yep. Correct, exactly. So, and that's the trick with this, because sometimes you are only given half the graph, but you need to know the full length of a period. So, given that everything with sine and cosine is symmetrical, if it takes 5 hours to get from your max to the min, then it's going to take 5 more hours to get from your min to your max. You have to make that conjecture on your own, okay? So this would be 10, 650. So now our period equals 10. So we would go to the period equals 2 pi over b formula again. Our period, or our length of one cycle, is 10. And we would again cross multiply. So we get 10b equals 2 pi, divide by 10, and b equals pi over 5. Or 2 pi over 10, which is pi over 5. Okay, so we've got b. Amplitude should be, once you have your midline, amplitude should be pretty straightforward. So what's the height of the curve above and below the midline? So from 385 to 120, so 385 minus 120 just tells us that our amplitude is 265. And we already talked about the fact that this was a positive cosine, so our A is a positive 265. And then what's the C? Phase shift, and this one is not shifted at all off the y-axis. Okay, so we have no phase shift there. It's technically a 0. I actually would be pretty surprised if they ever had you on a writing your own do a phase shift, but C is technically 0. So we've got our A of 265, which we had already known the answer was A, so I'm just going to compare this to A of 265. Our B we said was pi over 5, but that's the same as 2 pi over 10. And then 385 is our midline. Okie doke. All right. Another terminal ray type question. Draw it out. So drawn in standard position, passes through the point. It's not a great point, but what quadrant is it in? 1. Positive and positive coordinates. So I'm going to do something here. So it'll be 0.508, comma, 0.862. And always I'm going to draw my triangle to that. Terminal ray. Drop your triangle. And if you have the coordinates of a point, then they've subtly given you 2 lengths of the triangle. Your x-coordinate gives you this leg, 0.508. Your y-coordinate gives you this leg, 0.862, and this was on the unit circle. So hypotenuse was 1. Even if they didn't give you that hypotenuse, your Pythagorean theorem could find it for you. Which of the following is closest to the tangent? So your angle is always the one created with the origin. So your tangent is just opposite over adjacent. A little bit of SOHCAHTOA in here. So we would just do 0.862. 862 divided by 0.508. 0.862 divided by 0.508. And we get 1.697. Okay? And oh, this one. Just an explanation, which, gosh, on the however many open response error, like 13 open responses. You get 24 multiple choice and, yeah, I think 13 open responses. You're probably going to have to provide an explanation on like 5 of them, which I talk about a lot as far as writing sentences that make sense is not one of our strengths. Oftentimes I can read what people are writing and I know what they're trying to say, but they're not saying it, and I can't say, oh, that's Luke, I know he knows what he's talking about, he's got it. We can't do that and give you points, unfortunately. Make sure what you're writing actually makes sense. So for this one, explain why the equation of this would fail to have any solutions. I'll let you think about that for a second. Why would this fail to have any solutions? And let's pretend, or maybe probably realistic about it, let's pretend that you're all sitting there and you have no idea where to even begin. You don't even know what they're talking about. What could you do with this to sort of try to wrap your head around what's going on here? Find the minimum. What makes you say minimum? Okay, so you're already probably a step ahead of where most people would be. They're thinking, like, what do they mean have solutions? Like, you already know that your solutions are where it crosses the x-axis, right? So what I'm getting at here, like, what should you do to even wrap your head around what's going on is maybe, like, sketch a graph of it and see what this even looks like. So 6 times the sine of 10x plus 8. Make sure my mode is in radians. It's not, because someone used my calculator and changed it to degrees, so I go back to radians. Anytime when you're graphing trig, start with 0 to 2 pi or 0 to 4 pi, and I always count by pi over 2 unless I need to count by more. And then I'll keep it negative 10 to 10 and just kind of see what this looks like at first. And that's a lot. But as far as solutions are concerned, she was dead on, right? Your solutions are going to be where it crosses the x-axis, okay? And f of x equaling 0. So when will this equal 0 kind of indicates, yeah, it's going to, when is it equaling 0? And so she has a great point. Find the minimum, okay? So how do you find the minimum? Right, so you would maybe say the minimum equals 8 minus 6, which is 2. And then your explanation can just be the lowest point that this graph ever reaches is 2. Therefore, it will never equal 0. That makes sense? So the lowest value the graph reaches is 2, and a little bit of that is justification. Like, we didn't write that in a sentence form, but our sentence is coming here. We know that, right? Explain means at least write one sentence. Justify, you can get away with just showing work. So the lowest value the graph reaches is 2. Therefore, it will never equal 0. Quick question for you on a side note. Why are there so many? I just went from 0 to 2 pi. Why are there so many of these? Right. Your frequency is 10, right? How about, so there should be 10 of those cycles prior to 2 pi, which is correct. But if you think about it from a transformation standpoint, when you multiply, like if this is the parent function, you guys talked a lot about transformations, right? If this is the parent function and you use a multiplier of 10 within the parent function, you're messing with this horizontally, right? You're actually compressing it horizontally by a factor of 10. So rather than having one cycle between 0 and 2 pi like is traditional for the parent graph, you've now compressed that by a factor of 10. which has caused you to have 10 of these cycles. Does that make sense? Did you talk about transformations with Trig, or did she kind of leave that alone? You did that. You can do trig and kind of talk about all this A, B, C, and D stuff without talking about transformations, but all the stuff you know about transformations still holds true with trig. This just compresses your graph by a factor of 10 and smushed 10 cycles in that distance between 0 and 2 pi, where typically our parent graph of just the sine of x, and I'm going to get rid of this amplitude stuff, delete. Right, so there's your compressed it by a factor of 10 versus your parent graph is just one curve in that 0 to 2 pi range. Yes? Okay. Same thing with this out front. This stretched the sine curve vertically by a factor of 6, and this shifted the whole thing up 8 units. So conceivably, someone's explanation could talk about that. They could, and they wouldn't really need to talk about the 10 so much, but based on transformation, your sine curve got stretched by a factor of 6, so its range was from -6 to +6 for a moment, but then when you shift that up 8 units, that -6 minimum that got shifted up 8 units now became 2, and now it doesn't cross the x-axis at all. Does that make sense? Okay, so a couple different ways to go with that. All right, jumping into sequences, and I meant to, is this it? Beautiful. I meant to bring the formula sheet. For sequences in series, your formula sheet contains arithmetic and geometric sequence formulas, so definitely make use of those. As far as series are concerned, and series are obviously when you're adding all the terms together of the sequence, right? So if you want a grand total, you do a series. It gives you the geometric one. It does not give you the arithmetic one, okay? That is one, like for my kids, that's on a flashcard that you have to know. This may differ. I don't know if Mrs. Zigai even used this formula with you, but the arithmetic series formula is this. Does that look familiar to Mrs. Zigai's kids? Not at all, because you did arithmetic series with summation notation, correct? Okay, so that's a little bit different than the way I teach it, but we can go with both. But there is this other formula that, did you use this at all? Right. That's funny. We do summation notation. We talk about what it means and what it does, but when it comes to like find the grand total of an arithmetic series or geometric series, my kids just use these formulas, and they're there, so that's why I kind of figured just plug in what you know. But so we can talk about that when we get there. But you do use the sequence formulas, right? Do you use these formulas at all? Okay. So this first one, a sequence is defined by C sub 1 equaling 15 and C sub n equaling C sub n minus 1 plus 4. So first of all, is this arithmetic or geometric? Arithmetic, because I'm adding 4, adding 4, adding 4. The other thing is, these give you the explicit formula. Did she talk about explicit? That sound familiar? Explicit formula versus recursive, and this one is definitely given to us recursively because it's based on the term before, C sub n minus 1. So if you want the 20th term, no one's going to sit there, hopefully, and if they thought people might, they might change that to the 200th term. No one's going to sit there and recursively go through adding 4, adding 4, adding 4, adding 4, 200 times or 199 times or whatever it might be. So for a problem like this, I always highly recommend that you start kind of listing the first couple terms anyway, just to get a feel for it, and then write the explicit formula so that you can jump right to the 20th term or jump right to the 200th term, whatever they're asking for. So for the arithmetic, we would have a sub n equals a sub 1, which is 15, plus n minus 1 times your common difference of 4. And then just plug in 20, or plug in 200, or plug in whatever they want to know. You can simplify it first if you want to, but if it's just asking you to find a sub 20, just plug in 20, right? You're technically only adding 4 19 times, so 15 plus 19 times 4, and we get 91. So they give it to us recursively, you translate it to an explicit so that you can jump right to the 20th term. Does that make sense? Okay. So this is where, do you guys just plug this into your calculator? Yeah, okay. And so I have found that the Regents is never going to make you go from 2 to 25. They never do that. They stick to smaller numbers always with a summation notation, so I kind of got to thinking that the reason for that is because if they're ever really testing summation notation, I don't think they're anticipating you using the calculator. I think that they're anticipating you using these formulas when you can. So that's why I didn't teach it to my kids. And I also have seen ones where they keep it in terms of variables. So your calculator, I don't know how that would work. Right, you still would have to do it by hand, right? So if this was I squared minus 3j and they had another variable in there, you would still have to do it by hand. So I'm just going to, you plug in your 2, you start by plugging in a 2, you're also going to plug in a 3, a 4, and a 5. So your starting index being at 2, your ending being at 5, and then add them all together. So 2 squared minus 3, then you'll do 3 squared minus 3, 4 squared minus 3, and 5 squared minus 3, plugging in from 2 to 5, getting all those values. 25 minus 3 is 22, and adding them all together. So 1 plus 6 plus 13 plus 22. And we get 42. Like 17 is going to be fun. I think that actually came from the samples when we get down there. This one, geometric series. So you guys, what would you guys do for this? You find the common ratio, which is times 3, right? So that's your R. And correct. So similarly, but I'm also just going to show you this other way, and we're still going to have to do that. But we would see geometric series, and we would immediately go to our geometric series formula. So we're looking for the series total, S sub n. This is this one right here. We know A sub 1 is 5, minus 5. We know R is 3. We don't know the nth power, but we know 1 minus 3. And so we would kind of be in the same boat. Like if we're using the formula, we don't know the series total, but we also don't know how many terms there are. Okay? We don't know how many terms are in between here to get the total number of terms that we're adding together. So, like you suggested, we would then have to go to the sequence formula. Given that we know the last term is 98,415, so that would be 98,415, equals our first term of 5, times our common ratio of 3, to the n minus 1 power. This will allow us to figure out what is that n number. So what term is that 98,415? Now this is just a kind of a log equation, so we divide both sides by 5. We get 19,683 equals 3 to the n minus 1. My kids would log both sides. You guys would natural log both sides, or what? Would you do log base 3 on both sides? Yeah? Okay, so Morgan, we would log both sides. They are going to log with a base of 3 on both sides, because log base 3 of 3 just cancels. So they would have log base 3 of 19,683 equals n minus 1, and then you would just add 1 to both sides. And if n is not a whole number, we got a problem, right? Because it can't be the 5.5 term. It's got to be the 5th term or the 6th term. So if you ever get a decimal answer for the number of term that you're on, you did something wrong. So to type this in, you'd obviously go to your math. Is it, where's our log? Log base. And log base 3 of 19,683. Take that answer. Good thing, and that's a whole number, but then we have to add 1 to that. We get 10. So that's just a little side profile work to figure out that, okay, now that's our 10th term. Now, you guys would then go to summation notation, right? And you'd go from a sub 1 to 10. What would you do? Yeah, or a first term of you plug in a 1 to 10. Whereas my kids would just put the 10 in here. So n is 10, so we would just put that 10 in there, meaning we're adding the first 10 terms, and that would give us our answer. So 5 minus 5 times 3 to the 10th. Take that and divide it by negative 2. And we get 14,720. Number 2. Good? So obviously a little variation how we do it there. But all the same stuff, just different technique. All right, and then on this last one, writing this in simplest form, okay? So here your calculator is not, this is what I'm talking about, your calculator is not going to be of any use here. So you just have to know the basics of how to do summation notation. So we plug in a 2 for I, and then a 3, and then a 4 for this part. So that would be a 2x plus 4, when I plug in 2 and 2, 2x plus 4, plus, I'm going to plug in a 3 for I, and I get 3x plus 2 times 3 is 6. And then I'm going to plug in a 4 for I, and I get 4x plus 8. So that's the first summation notation, which altogether is going to become 7, 9x plus 18 minus. Now my second summation notation, I start by plugging in a 0. So what's 2 to the 0 power? 1, so that's 1x minus 3. I plug in a 1, 2 to the first power is 2, so that's 2x minus 3. And I plug in a 2, 2 squared is 4, so 4x minus 3, which grand total becomes 7x minus 9. But I'm keeping this in parentheses because I obviously have to subtract the whole sum. So organization is key here, and then it's just distributing. So 9x minus 7x is 2x, and 18 minus negative 9 is a positive 27. Does that make sense? Good. Okay. So, I'm thinking, is there anything in particular you want review on? I can do a couple different things. I can go through some of these like sample questions that aren't in the green book. I still need to text Mrs. Zigai and find out about your green books. But is there any topic in general that there's a video on the polynomial stuff. Maybe we just, Luke, you look like you're trying to come up with something, so I'm going to let you brainstorm for a minute. Did you get green books? Yep, we can talk about those. Well, there's trig there's one main trig identity. Yeah. Yeah, the trig identity, that's the Pythagorean identity. Sine squared x plus cosine squared x equals 1. I've only really seen this in like one context of, they'll say like sine squared of 0.7 plus cosine squared of x equals 1. What's the value of x? So just kind of knowing that it has to be the same thing. I'm not really sure why that's in there. I don't know if I have no idea. Sometimes we can't figure out and we can't predict why the state puts certain things in there. I've never really seen it used in another context before. It pretty much comes from the Pythagorean theorem though. So do you guys know this on a unit circle? If you're given a point, that the x-coordinate is the cosine of your angle and the y-coordinate is your sine of your angle? So you guys know that. So, still with a problem like this, I would draw my triangle. And since my x-coordinate is cosine theta, I would name this cosine theta. My y-coordinate is sine theta, I would name this sine theta. And it's the unit circle, so that's 1. So, obviously it makes sense why the sine squared of theta plus the cosine squared of theta equals 1. It comes from the Pythagorean theorem. That's why it's called the Pythagorean identity. So it does tie into all this. I'm just not sure. You know, I've seen it in that context as a multiple choice, although we just did one in our class the other day. It came up on one of the practice tests. Shoot, let me run to my room and get it, because it was on, I put it on your homework list, I think. And that's a good question. Give me 2 seconds, I'm going to go over and grab it. You can look at it. This uses it. Have you guys seen that question? This is Big Eyes Kids. You've never seen that question? Okay, so this uses it. And it tells you, use the identity, but it tells it to you. Find the value of tangent to the nearest hundredth if the cosine of theta is negative 0.7. So if they're giving you the value of cosine, and they're also telling you it's in quadrant 2 for that matter, but they're giving you the value of cosine. So you'd plug it in, and they're just giving you cosine. They're not telling you cosine squared, so you've got to plug in negative 0.7 and square it on your own. And so with this, I would square it out, so sine squared theta plus 0.49 equals 1, and you'd want to solve for sine, so subtract the 0.49 over, and then square root both sides, so the sine of theta, and again we've got this plus or minus question, okay? But they tell us we're in quadrant 2, so you guys tell me, what is sine if you're in quadrant 2? Is it positive or negative? Positive. So we would stick with positive root 0.51. Okay? So given that we now know sine and we were told cosine, if they're asking for tangent, there's a couple ways that you can do this. I think the easiest way is just to know that tangent is sine over cosine. Do you guys know that? Tangent is sine over cosine. So I would know that the tangent of theta is just the sine value, root 0.51, over the cosine, negative 0.7, and just type that into my calculator. Root 0.51 divided by negative 0.7. Okay? if that wasn't fresh out on the, tip of your tongue, that tangent equals the sine over cosine, the other way to do it is to kind of, again, your terminal ray is in quadrant 2, draw that triangle. You know that the coordinate is the cosine of theta, so negative 0.7 as your x-coordinate, and the sine of theta, we just said, is root 0.51. Let that label your triangle for you, so this is negative 0.7. Your y-coordinate, root 0.51, gives you that, and then there's your angle, and your tangent is opposite over adjacent, okay? The whole opposite over adjacent thing ties in with the sine over cosine thing. That's your y-coordinate, sine, over your x-coordinate, cosine. Does that make sense? Okay? I don't know if you'd be able to do that on your own, but hopefully it makes sense, seeing it now. But I'm such a fan of, to me, the right triangle drawn in the unit circle can do so much for you. It can eliminate your need to memorize all this other stuff. As long as you know cosine, sine, and you can label your sides and do the Pythagorean theorem, and SOHCAHTOA, everything can always come back to SOHCAHTOA and the Pythagorean theorem. It doesn't have to, but it can. Obviously, I avoided all of that by just knowing the sine over cosine, but if you don't, everything can come back to that and still work. All right? How's that? Is that what you were looking for, Luke? Yeah. Good. That exact problem, I'm sure. So, we're going to... Oh, she does have them for you. It's not, oh no, you want to see the practice exams, right? Yeah. And to be honest, that's something that you guys could do in your week off between, right? Because we end school Friday. That week you could kind of do mainly the 3, well, you can use my website because I've got all the solutions on there. So you could always use my website to pull the solutions for all the exams out of those books. There's 6 exams in the green book, but really only 3 of them are true Regences that have been given. The other 3 are just kind of good practice problems, but they're not actual previous test questions, so they might not be as strong, but they're still all, good questions. But as far as the actual 3 Regents exams, 2 of them I have solutions posted for, not the work though. That would be the downside. But on the 3rd exam, I actually have a video of me doing it, under this screen that you'd actually be able to watch me. That was the one that was given in January. I haven't posted that yet, but I will post that eventually for my kids, and then you guys can use anything, obviously, on my website. So, I'll try to remember on Monday, if I don't have my child by Monday. If I am not in school, just tell your substitute they're in her filing cabinet and ask her if she can give you all one, because that's what they were meant for. It's for you to have them. And the solutions will all be on my website. So that's that. The only set of questions then that you won't have access to in the green book are these sample questions, and for the next 10 minutes we can just look at a couple of these. These were the questions before the exams where we had any exams. So, a multiple choice question, which graph could represent the sketch of this p of x function? So, negative a, an x plus b in parentheses, and then an x squared minus 2cx plus c squared. So, what are we looking for here when we try to pick which graph would work? When it's all in variables, it's not as easy, right? And behavior. So what is the degree of this polynomial? Because that's not that obvious either. 3. Because this is an x squared times another x. So overall it's an x to the 3rd power. And the leading coefficient is, these are all 3rd degree. So that's not really that helpful. But because it's got a negative coefficient, which two can you know it's between? Morgan? I'm not sure Mrs. Big Eyes kids do it the same way we do it. So I'm looking for you to tell them. It's a negative odd. No? You girls know? 1 and 2. What did you base that off of? Right. So, and I give my kids these 4 graphs. So, a negative x to the odd power has, like, opposite end behavior because it's odd. But because it's negative, it's overall got a negative slope. So, it starts high and ends low. Versus a positive x to the odd power starts low, ends high. Okay? So, because, and I'll just do the even ones, negative x to the even, same end behavior, but like a quadratic, opens down if it's negative a, and if it's a positive x to an even power, it opens up. So this being odd and being negative means it needs to start high and low. So it's between 1 and 2. 3 and 4 are out. And then probably this is the next best place to look. If x plus b is a factor, what's the root? Negative b. And so which one of these has a root at negative b? Right. Does that make sense? Okay. You could factor this into x minus c squared. So that should tell you that you have a root at c. If the factor is x minus c, you have a root at c. Not only is it a root, but it's a double root. So it should bounce off of c, which this one does. Does that make sense? Okay. So getting at all that behavior, but without numbers, it's just kind of a different beast. Focus directrix stuff. Have you guys done enough review on that? Okay. So my kids, when on the back of our flashcard, it says point to focus has to equal the point to the directrix. So I'm a huge fan of sketching here. I don't think I could do this without sketching. I wouldn't want to try to. That would make me have to think too much. I prefer to write things down and not think. I prefer physical labor to mental labor, I guess, is what that boils down to. But when you draw your focus at 4 and your directrix at 2, your vertex always has to be halfway in between. Okay? I will also tell you this with these questions. It has been most common for us to give you questions where we give you the focus and we give you the directrix. And so when we give you the focus and we give you the directrix, the vertex always has to be halfway in between. But lately, when the state has put questions on the test, what we have been finding is that they've given you the focus and the vertex and asked you to find the directrix, which isn't hard, but I just get nervous that we're so used to giving you these two that you're always going to go halfway in between. That's only if they give you the focus and the directrix. Then you go halfway in between. But if they give you the focus and the vertex, you're going to have to go an equidistant the other way to get the directrix. Or vice versa. If they give you the directrix and the focus, you're going to have to figure out that's 6 units away, so you have to go 6 more units away to find the focus. So it can go either way. Okay? But at the end of the day, you should be able to know the focus and the directrix, and you should always be able to draw in your parabola. Your parabola always bends away from the directrix and contains the focus. And so this comes in with our distance formula. So we always pick a random point, P, and we always call it XY. And then our focus we should know the coordinates for, and our directrix we should know at least the value of it, right, by the time we figure out these 3 things. So this is at y equals 2, so I would label that coordinate x comma 2. And then it's the distance formula, point to focus, point to directrix. So point to focus distance formula is going to be x minus 0 squared plus y minus 4 squared equals, and then point to directrix is going to be x minus x squared and y minus 2 squared. Always with these, you're going to have something that's 0. So I would take my x minus x right out of the gate and just cross it out. Your square roots on both sides are also going to cancel out, because you'll always just square both sides, and those will be gone. Then you're going to be left with 3 sets of parentheses, 2 of which are the same. The 2 that are have the same variable, I should say. The 2 that have the same variable, those are the ones that you actually want to factor out, or you actually want to multiply out. This I would leave alone, although this one's kind of funny because it's x minus 0. But for y minus 4 squared, y squared minus 8y plus 16. And then for this one squared, y squared minus 4y plus 4. So when you square out the 2 with a matching variable, your y squareds should always cancel, and then you just have to get y all by itself. So move everything away from the parentheses, I would say. Move your y terms away, so add that 8y over, and then get rid of your constant, so 4 can be all, or so the y's can be all by themselves, so we subtract the 4 over, and we get x minus 0 squared plus 12 equals 4y. And then we're one step away, just divide both sides by 4. So this one is typically written as 1/4. Now I know it seems silly that I keep writing that x minus 0, but I'm doing that for a reason. Because the vertex form of a parabola is y equals a times x minus h squared plus k. You guys know that? Where hk is your vertex. So I kept this in parentheses even though it was 0, so that we could clearly see what our hk was, 0, 3. And that should be a good checking point because we have a picture. We should know where our vertex is. It's at 0, 3. The big point of all of this is not because we didn't already know what our hk was. We did. It was to find out what the a value was. And we find out that the a value is 1/4. So of our answers here, the answer is 4. Yep. Do you not know it clearly? Well, x2 minus x1 squared plus y2 minus y1 squared. So if you want to write that down, but that's the distance formula between 2 points. Okie doke. Maybe at some point I'll throw this packet on my webpage. I mean, I don't know if I will have time to throw solutions together with it, but it's just more questions to keep you busy that week between. It's kind of a bummer. I kind of wish your final was just on Monday so you could get it over with, right? And class on Friday, just have it Monday.